Hi everyone, and welcome to the module Water Technology. Before stepping to the lecture, let's recap the lecture 1. So in this previous lecture, we have discussed the sources, importance and types of water, that is hard water and soft water, and different types of impurities present in the water, namely physical impurity, chemical impurity and biological impurity. And we discussed what are all the disadvantages of hard water in industries and why the treatment process are required. So all these things we have discussed in the lecture 1. Right? So let's step into the next lecture series. Let's go to the lecture 2. In this lecture, we are going to discuss about the external treatment process. So water used for industrial purpose should be pure, that is, it should be free from hardness, scale forming substances and corrosive agents, etc. So the process of removing hardness producing substances from the water, it is called softening of water. So the softening of water can be done by two ways. One is external treatment process, which is going to discuss in this lecture, and the next one is the internal conditioning process. So in the external treatment process, it involves the removal of hardness producing substances from the water before feeding into the boilers. The external treatment can be done by different methods. Two methods are given here. One is zeolite process and another one is demineralization process. All these process works under the ion exchange mechanism. So how the ion exchange mechanism, how it works? Just look at this images. So you can easily, the name itself we can understand the ion exchange process, which indicates the exchange of ions will happen. So you can take the best example over here. So here we have a cation exchange resin, which means that this is a cation exchanger. So this can capable of exchange cations alone. So this can be exchange cations. In case of anion exchangers, the name itself we can understand it can be capable of exchanging anions. So how it works? So just look at this image, and here these balls, yellow color balls, ball-like structures are called ion exchangers. Here the waters, hard waters, which means that the calcium and magnesium ions, the untreated water, is allowed to pass through these kind of ion exchangers. The ions will be exchanged with the respective ion exchangers, and the ion-free water will be collected in the bottom. So what is ion exchange mechanism? So it exchanges ions depending upon the resins. So let's go to the topic. So again, we can see one more example how the softening cycle will happen. So just imagine this is in the picture 1. This is the yellow color beads, bead-like structure. This is called ion exchangers. If the hard waters enters into the containers or bed, and the red color spots, which indicates calcium and magnesium ions. This calcium and magnesium ions is allowed to, the hot water is allowed to pass through these ion exchangers. The ions like calcium and magnesium will be exchanged. The free calcium and magnesium free water will be collected at the bottom. So similarly, we can increase the number of cycles. After that, after certain time, the exchange resins will get saturated. Look at this image. The complete compare these images 1 and 4. Here we have a yellow color bit, and here completely ions are exchanged. So it is represented in the red color. So completely the ion exchanges gets exhausted. So what's after next? So again, we need to regenerate the ion exchangers. After that, we can use it. Again, the cycle starts from 1, 2, 3, and 4. Again, we will regenerate it again, and we can use it. This is the most advantage of the ion exchanges. Let's go to the topic and zeolite process. So in this process, the hot water is passed through the bed of zeolite, and it removes the hardness causing ions, calcium and magnesium in the hot water, which is replaced by the sodium ions in the zeolite bed. Okay, what is zeolite? So the zeolites are naturally occurring material, and this is a combination of hydrated sodium aluminosilicate, Na2O, Al2O3, 4SiO2, and 2H2. This is a natural zeolite, and the synthetic form of zeolite is known as permutate. Either they may ask the zeolite process and permutate process, both are same. If it is a naturally occurring material called a zeolite, the same combination can be derived from synthetic route, so that is called permutate process. This is the exchanger softener. It is widely used in all the areas. So the zeolite, sodium zeolites represented as Na2Ze. So look at this image. In this process, the hard water is passed through the bed of, here we have sodium zeolite bed. So this is an exchanger. If the hard water, this is the hard water inlet. If you pass the hard water, which means that which contains hard water, which contains calcium and magnesium ions, the hard water is allowed to pass through the zeolite bed, and after that it passes through the gravel for filtration process. The ions from the hard water, that is calcium and magnesium ions, this is completely replaced with the sodium ions in the zeolite bed, and calcium and magnesium free water will be collected at the bottom. It is the reaction. Look at this. This is a calcium bicarbonate, which is available in the hard water. Okay, this is a sodium zeolite. This is here. Okay, so how these reactions, how the exchange reactions can be represented in the equation form, and here this calcium ions will be replaced by sodium, and we will get calcium zeolite. Similarly, magnesium bicarbonate. So magnesium bicarbonate plus sodium zeolite, this magnesium ions replaced by sodium, and we will get magnesium zeolites. Okay, like a calcium carbonate, calcium bicarbonate, calcium sulfates, calcium chloride, etc. So this will react with the sodium zeolite. The calcium and magnesium ion in the hard water is replaced by the sodium ion in the zeolite bed. So after the softening process, the zeolite is completely converted into calcium and magnesium zeolites. See the products. And it gets exhausted. At this stage, the hot water supply is stopped and the exhausted bed is regenerated by treating with concentrated 10% sodium chloride solution. So see, look at this equation. The exhausted zeolite is in the form of calcium zeolite or magnesium zeolite, and this will be treated with 10% sodium chloride. Again, we can regenerate it. Look at the previous. Again, the sodium zeolite will be regenerated. Again, it is used for softening of water. There are some advantages of zeolite process. This process removes hardness up to 10 ppm. Operational cost is very less, and the equipment is used is compact. There is no sludge formation. The sludge means it is a slummy and loose precipitates. The plant can be connected to the water supply line itself. This avoids double pumping, requires less time for softening process. But there are few limitations are also there. The major limitation is the first and foremost thing is the process of exchanges only happen to the cations, that is calcium and magnesium ions with the sodium ions. It does not remove any anions like bicarbonate, carbonate, or chloride or sulfate, etc. So these are all the major disadvantages. In order to overcome these issues, again, the next process was developed that is called demineralization process. Nowadays, this process is used in the industries and other softening of water areas. So here we will use two exchangers. One is called cation exchange resin and another one is called anion exchange resin. In this method, the exchange resins are used as softening material. In this process, cations like calcium and magnesium and anions like chloride, sulfates, carbonates, bicarbonates, which are responsible for hardness, are completely removed with the help of cation exchange resin as well as anion exchange resins. So the name itself we can understand cation exchange resins, which means that this can be capable of exchange cations, and anion exchange resins, which can capable of exchange anions. Look at this picture. This is the schematic representation of demineralization process. In this process, the raw water, that is hard water, it is a double bed column. When we consider in the zeolite process, it is a single bed column. It is a double bed column. Okay? So the hot water, okay, the hot water first passed through this cation exchanger, and the cation free water is allowed to pass through the second bed, that is called anion exchanges. Here some spelling mistake, T will not be there, and this is an anion exchanger. And cation free water is allowed to pass through the second bed, which contains anion exchanger, and cation and anion free water will be collected at the bottom. Okay, so in this case, the hot water is first passed through the cation exchange column, and which absorbs all the cations like calcium, magnesium, sodium, potassium, etc. present in the hot water, and the cation free water is allowed to pass through the second bed, and which absorbs all the anions like calcium, sulfate, carbonate, bicarbonate, sulfates, and chloride, etc. present in the water, and the anion free water will be collected at the bottom. Okay? So the reactions at the cation exchange resins, what will happen, the chemical terms? So here, what kind of materials can be used as a cation exchange resin? That is the question arises. So resins containing acidic functional group, that is COOH or SO3H, are capable of exchanging their H plus ions with the cations of hot water. Look at these exchangers. Exchangers are represented by RH, and the anion exchange resins will be represented as OH. So acidic functional groups that will be acting as cation exchange resins. Anion exchange resins are called as OH, basic functional groups. So resins containing basic functional groups are capable of exchanging their OH minus ions with the anions of hot water, and cation exchange resins contains then acidic functional groups are capable of exchanging their H plus ions with the H plus ions with cations of hot water. Look at this image. This is an example for cation exchange resin. Here we have in the surface of cation exchange resin, we have H plus ions, and the incoming cations will be replaced by H plus ions, and the H plus ions are emitted from the resins, and after a certain time, this will get exhausted, and the exhausted resins can be regenerated through certain process. So we will see the regeneration of cation and anion exchange resins. So after the process, look at this process again, and here the cation exchange resins. This is cations, calcium, magnesium, sodium. This will be replaced, and the final product is R2C. So R2Mg and the RNA. Similarly, in anion exchange resins, the OH minus ions, exchanging of OH minus ions with the anions of hot water, anions like chloride, sulfates, carbonates, bicarbonates, etc. And RCl and R2SO4. These things are exhausted resins, exhausted anion resins. And this is an exhausted cation exchange resin. Similarly, just it is a reverse process that is called regeneration that we will see in the next slide. And the exhausted cation exchange resin bed. The exhausted cation exchange resin can be regenerated with the help of sulfuric acid. And the exhausted anion exchange resins can be regenerated with the help of sodium hydroxide. So we know that the cation exchange resins should contain the acidic functional groups. Anion exchange resin should contain basic functional groups. So with the help of acidic medium, we can regenerate the cation exchange resin. With the help of basic medium, we can generate anion exchange resin. So in the next lecture, we will discuss what are all the internal conditioning processes are there to treat the water. Thanks for watching. If you have any queries, please comment on this. Thank you.